Alright, so we are going to look at the T-beam in this problem, and we are going to determine the maximum shear stress in the beam and the max force that we're looking at is 2,000 pound force between B and the end of the beam, and our shear stress calculation, the equation for that is over here, and once again Q is our first moment of area, okay, and we're calculating for this cross section the T-beam. So looking at that, we have this Y is our location of our neutral axis, and we're also going to have a B value, which is our thickness at the neutral axis of our component. So if our B value was up here in this T, upper T portion, then it would be, let's see, that's 3 inches. Okay, there we go. It would be 3 inches instead of 1 inch. Okay, so we're going to calculate the area. For the area for this top section is 3 inches across by 1 inch tall, and 2 inches tall here by 1 inch across. So we have a total area of 5 inches squared, and then we want to calculate what our Y value, our neutral axis location is. So we're just going to use, we're going to go from this bottom point as a reference point. You could start from the top, you could, I recommend starting from the bottom or from the top, but we're going to go from the bottom here, okay? So we have this area, this top area up here, so that's all it is that area times its location. So this is 2.5 inches, so the centroid is located about there, and so that's 2.5 inches, so multiply the area by 2.5 inches. Similarly for the bottom, area is 2 inches by 1 inch, multiplied by, okay, the centroid is here at 1 inch. So multiply by 1 inch, and then add those together and divide by the overall area, which we said was 5 inches, and we end up getting 1.9 inches is the location from this reference point that we used. So we got 1.9 inches. Okay, we are in this bottom half of the T, and our B value is going to be 1 inch across. Okay, now just to think about this creatively, if we had a larger area up here, so maybe if this portion up here were not 1 inch tall but 2 inches, then that would push our B value up into this section up here, because our neutral axis would be pushed up here. Said another way, that would move our neutral axis up here because there would be a higher amount of area located up here, and we're trying to balance the area. So where is the neutral area point? Okay, well, it's right here. In that case, if this is 2 inches, there's more area up here. So our neutral point would be somewhere across here perhaps, and then our B value would of course be the 3 inches instead of the 1 inch B value here. Okay, so hopefully that clarifies that concept a little bit. Now for the T-beam, you can look up how to calculate the inertia. There will be an equation in a table you could use. That's probably the simplest way to go about that. At the neutral axis, the Q value is the area times the neutral axis distance from the reference, and that's 1.9 inches, so A times Y is 9.5 inches cubed. And we said the thickness B is 1 inch, and we are just going to plug all of that into our equation for shear stress, the maximum shear stress, and there we have it. So good luck calculating these.